Ladies and gentlemen, join me in this video. I want us shortly to basically look at the issue of spectrums. Now, we said when we were introducing the issue of the photoelectric effect, we said that light has a dual nature, meaning it can behave as a particle and it can also behave as what? As a wave. So then now we said light, it's made up of small particles that are called what? That are called photon. And then we further explain that a single photon carries a quantum of energy which is equals to the Planck's constant multiplied by the frequency of the light. In case you're given frequency, should it happen that they give you the wavelength, then we are saying the energy of a single photon is equals to the Planck's constant multiplied by the speed of light divided by the what? The wavelength. That's what we said. And then when you look at the first equation, if we can make h the subject of the formula, because that's the constant, meaning it doesn't change. So if we make h the subject of the formula, it means our h is gonna be E all over the what? All over the frequency of the what? The frequency of the light. So we can all see that if this is kept constant, it means the energy of a photon is directly proportional to the what? Directly proportional to the frequency. Meaning, if you change the frequency, it affects the energy of what? The energy of a photon. So once the energy of a photon is affected, then now it means the speed at which electrons are injected will also be affected. So meaning, as a learner, you need to know that change in frequency affect the energy of a photon. Then now as the energy of the photon is being affected, then it means the kinetic energy of the photon as well as the kinetic energy with which the electrons are injected from the surface of the metal, it will also do what? It will also change. So then now, the second part of it is when we are looking at the whole part of a spectrum. So then now, as a learner, you need to know that we've got two different types of spectrum. The first one, we've got what we call the emission spectrum. And then the second one, we've got what we call the absorption spectrum. So as a learner, you must be able to differentiate between these two types of what? Of spectrum. So then when talking of an absorption spectrum, that one, it is formed through the issue of a cold gas. Then now when talking of an emission spectrum, that one, it is formed or it revolves around a hot gas. So that's the first difference. A cold gas will result into an absorption spectrum. A hot gas will result into a what? Into an emission spectrum. So then now, let's just assume we are having this cold gas. We are having this cold gas. That's what we are having, right? This is our cold gas. This is our cold gas. For example, there is our cold gas. So then now, immediately when we strike this cold gas, remember this gas, it is made up of what? It is made up of electrons. So when we strike this gas with an electromagnetic radiation of suitable light, so then now we are expecting light rays to strike the gas. So as the light rays strike the gas, the electrons of the cold gas will then gain energy. Are you with me? They gain energy, meaning the light, immediately when the light strikes the cold gas, then the electrons of the cold gas will then gain energy. in as much as the temperature of the electrons will do what? Will changes. So as the temperature changes, it means these electrons, they are gaining energy. So what will happen? Electrons, when they move on energy levels. So we're having energy level 1, having energy level 2, having energy level 3, and having energy level 4. So then now, this part here, we are placing these electrons, right? We are placing these electrons. Now, at this point where the electron is, it is called the ground state. So the electron is on the what? On the ground state. So then now immediately when the light rays strike this cold gas, like I've been explaining, the electrons gain energy. So as the electrons gain energy, they then start to jump from one energy level to another energy level. So in other words, this electron will move from the ground state, which is the lowest energy level. They'll move from the ground state up until the electrons reaches the what? The highest energy level. So then now, as a learner, what is it that you need to know? You need to know that as the electron move from the ground state, which is the lowest energy level, to the highest energy level, then the absorption spectrum occurs, because like I've said, that immediately when this light strikes the cold gas, then the electrons absorb energy. So they absorb the energy so that they can jump or move from the ground state to the highest energy level. So meaning, when you are explaining absorption spectrum, it occurs when an electron moves from the lowest energy level to the what? To the highest energy level. So this highest energy level, this one, it is called the what? It is called an excited state. So the excited state, it's not stable. As a result, the electrons, they don't stay there for a long period of time. They only stay there for a short period of time. Then now after that, this electron will then bounce back to the what? To the ground state. So as it bounces back to the ground state, then an electron is what? Is then emitted. Right? The electron is then emitted. As a result, we are producing what we call an emission spectrum. So emission spectrum occurs when the electrons moves from the highest energy level, which is the excited state, to the lowest energy level. So the emitted electron, or the emitted photon, then results into the what? Into the formation of different frequencies, of which in this case of the emission spectrum, these different frequencies which are produced, they appear on the what? They appear on the material. So then now, in finding the energy of the photon, as a learner, you need to know that now the change in energy will be the what? The energy of the photon, which is the higher energy, minus the what? Minus the lower energy, meaning the energy of the photon will be the difference of the what? Of the two energy levels. Thank you for watching. Please follow me for more.